Hello students, welcome to my channel. Today I am going to explain about a problem on resolution of forces. Problem on resolution of forces. The three forces of magnitude 40 kN, 50 kN and 20 kN are acting at a point O as shown in figure. The angles made by 40 kN, 50 kN and 20 kN forces the x-axis are 60, 120 and 240 respectively as shown in the figure. So determine the magnitude and direction of the resultant force. So three forces are acting at different angles with x-axis which are acting at O. So we have to find the resultant of these three forces. Okay. So now we will see the solution. First of all, write the given data. Okay, first of all, write it given data. That is given data. You have to write it given. That three forces are given. Let three forces F1, F2 and F3. So F1 is equal to 40 kN. F2 is equal to 15 kN. And F3 is equal to 20 kN. So these are three forces, F1 and F2 and F3. So these three forces are acting at different angles with x-axis. So try to write the angles also. Okay, angles are, let the angles theta 1, theta 2 and theta 3. So theta 1 is equal to 60 degrees, theta 2 is equal to 120 degrees, theta 3 is equal to 240 degrees. So these are three angles of forces with x-axis. Let theta 1, theta 2 and theta 3. So we have to find the resultant of all these three forces. For that we have to resolve each force along x and y axis. Okay, so now we'll see one by one. For 40 kilonewtons, I am resolving it into along x-axis one component and along y-axis component. So x-axis component is cos, y-axis is sine. Similarly, 15 kilonewton also along x and y, and also for 20 kilonewton x-axis and y-axis. So after resolving these three forces along x and y directions, so we have to sum all the x-axis and y-axis components for getting a resultant of all these three forces. Okay, so after resolving these, try to write the sum of all the three sum of all the components of forces along x-axis. Okay, we know the formula for this. You can say it is a sigma h, or simply you can say it is h. You can take it as HR sigma h is equal to along x component is cos theta. So F1 cos theta 1 plus F2 cos theta 2 plus F3 cos theta 3. So this is all the horizontal components of all the forces. Similarly, along y-axis, that is the vertical components of all the three forces, that is along y-axis, is equal to sigma v is equal to F1 sin theta 1, F2 sin theta 2 plus F3 sin theta 3. So these are the sum of all the horizontal components and sum of all the vertical components. Now we have to submit the force and angle values in the above equations. Okay, substitute the force and angle theta values. So h is equal to, or sigma h is equal to f1 40 into cos theta 1 is 60 plus f2 15 cos theta 2 120 plus f3 20 cos theta 3 value 240. Okay, try to simplify this equation. 40 into cos 60 value 1 by 2 plus 15 into cos 120 also minus 1 by 2 plus 20 into cos 240 minus 1 by 2. So try to simplify this equation. We will get the value of sigma h is equal to 20 minus 7.5 minus 10 is equal to 2.5. 2.5 kilonewton is the sum of all the horizontal force component. Okay, similarly substitute the values of force and angle in sigma v also. So now sigma v is equal to 40 into sin 60 plus 15 into sin 120 plus 20 into sin 240. So simplify this. Sin 60 root 3 by 2 plus 15 into sin 120 root 3 by 2 plus 20 into sin 240 minus root 3 by 2. Okay, so 40 to 20 root 3 plus 15 root 3 7.5 root 3 minus 10 root 3. So it is equal to 17.5 root 3. 17.5 root 3. 20 minus 10, 10 plus 7.5. 17.5 root 3. That is the value. Now resultant R is equal to, the equation is root of sigma v square plus sigma h square. Okay, so resultant magnitude of resultant magnitude R is equal to root of h square plus v square or sigma h square plus sigma v square. That is the formula. So magnitude, that is the magnitude, and resultant direction is equal to theta or tan theta is equal to v by h. So substitute the sigma v and sigma h values in our equations. So we will get the resultant R value in magnitude and direction theta value finally. Okay, this is the solution of problem.